So we're here at Analog Devices, and who are you?
Hello, my name is Jan and Broeders, responsible for business development for healthcare at Analog Devices.
So what is Analog Devices doing for healthcare?
In fact, what we are doing is trying to sell you complete solutions. So what you see here is a wrist-worn device that includes a complete analog...
This one, right?
Yes.
So this is no Analog Devices here, it's just the one?
Yes, it's an analog watch, the other one. So, but the device internally actually has a complete solution for measuring optical heart rate. So what we do is sending light into the tissue and we measure the reflection coming back from this. And everything integrated in a single module.
How reliable is it compared to the best way possible to measure heart rate?
Reliability is one of the anchors where we're focusing at, since you are applied to motion with these kind of measurements, but also ambient light, and that's where we try to do best. So we have solutions to cancel out the motion artifacts as well as the ambient light to have a reliable reading.
Is your solution here, your SoC, is it Cortex M3?
That's correct. So we have a Cortex M3 that consumes only 40 microamps per megahertz. So very low power to extend the battery lifetime of your application.
Is it one of the lowest power Cortex M3 in the world?
It is.
It is the lowest, maybe.
It's the lowest at the moment. People, of course, are catching up, but from that perspective, we have the complete solution from sensors, including the radio and the processor.
How do you make it so low power?
It's a combination of the process that we're using and
it's
the
very small process node, or no?
The process node is small on this processor, and in fact, it's a complete family that we are developing. So for this, you have analog and digital integrated in one module.
That's why it's called Analog Devices, because you're very good at analog stuff.
That's it. So that's where we come from.
And so heart rate monitors are in a bunch of smartwatches and fitness trackers around the world. Is it your solution that's in theirs?
Not in everyone, but we are a big player in this market. So we have our sensors integrated in those applications, and it's not just the optical sensor for measuring the heart rate, but we have also the motion sensors built on MEMS technology, dissipating very little power. So we have a sensor that runs from 1 microamp.
Where is Analog Devices based?
We're actually in a US-based company, so located in Boston, where we have also development and production facilities.
Around the world?
That's what we do around the world, but in Boston we have a big campus where we have thousands of people working on new developments.
And here's some demos showing the same sensor.
Yeah, so you have a sensor that is including the LEDs and the photodiodes. Everything behind the glass window. If you focus in on this board, you maybe can see it behind the glass window as well. There we have a tiny device that includes LEDs, red and infrared, optical sensors, and the analog front end.
All right. And right here?
That's the interface board. So there was the previous generation. Everything that you see here is now integrated in this wrist-worn device to make it easier to evaluate.
Is Analog Devices doing all kinds of other stuff with healthcare?
Oh yes, yeah, we still also in the professional world, so we're making front ends for scanner technologies, CT imaging, X-ray, but also ultrasound.
Can we look at what's over here? This is a vision-based CMOS sensor. What is it about?
So in fact what you see here is actually a complete solution where we have a sensor, so an optical sensor, able to measure occupancy. And with a Blackfin processor, we make it a complete solution for instance, independent living. So what you see on this sensor, it's a 360-degree sensor, and you see here 2 hotspots of the 2 persons sitting on the table next to us.
Where is it?
So the sensor is on top, is there.
Is it 360?
360-degree watching.
And how many
facing
degrees?
to the right. It's facing to the right. So
and then it's 220 or something.
180. It's 180.
180.
So you see the 2 people, on the table sitting over there, with these 2 red flags.
So it's for detecting heat. Living people.
Or occupancy, in a room. So sometimes, in a room you want to switch on the lights when there are people. But for rescuers, it would be good to know how many people are in the room, and that's actually what we do with this kind of sensors.
All right, and over there, what are you talking about over here? Let's go check it out.
Eliminate a battery? Or are we just trying to,
Can we just jump
assist
in here?
the battery?
And so, sorry, what is this?
So what do we have here?
So
actually
yeah,
is
so
an,
we can definitely talk. Send me an email. I'll send it back, and we'll.
So we're using a
go through all
PV
those
sensor,
details.
and the PV sensor is collecting light or energy.
So this is,
And on this board we have a step-up converter that is able to step up as for voltage as low as 70 millivolts.
Yeah.
And this 70 millivolt is converted into a 4-volt output to charge batteries or superchargers. The effect is an autonomous sensor, so it's a sensor board with a radio and a temperature sensor, and it's running from just an old PV cell.
So it's running from a solar through a supercapacitor.
Yes, and then you need for this a boost converter, of course, so to charge the cell.
Okay, so let's go check out this one over there. This is the last demo you have over here. So what are you showing over here?
Towards the sensor. So this is a solution that Roman and his guys put together.
This is
It actually has a
something
patch
called
antenna.
zero-pin sensor.
So it's a patch
the
antenna,
reason
and there's
for
an
the name is
accelerometer
that
on
we
this,
have,
and a
sensor
microcontroller
node
and a
complete system,
transceiver.
accelerometer.
So it's
Accelerometer,
That board there would
humidity,
actually create
temperature
an energy
sensing, radio chip, microcontroller,
push it
and
towards the sensor.
RF to DC
over short
conversion.
distances. We're not talking meters. We're talking
Nice. What does it do?
right?
So
Think
we
about-
transmit energy
See how this is moving
from
like this?
one sensor, and from the transmitter we receive it on the other hand. And while it's rotating, you can measure the equipment to monitor the equipment for
Monitoring.
vibration working. Yes, machine monitoring.
And in order
So it's for monitoring
For
machines.
monitoring machines, yes.
All right. And what is this one?
The RF.
So this is actually,
then does it-
if I can use
Yeah.
the mic
Yeah,
for
go
a
ahead.
second.
And
So
then
this is
actually
the same board,
does a,
but with the mounting cover.
does a
So you're gonna
transition
mount
or
it
does
on your
a,
ceiling,
a conversion
and this one is gonna be mounted on the rotating part. So it
How far from
rotates.
each other must they be?
So the target application is about 20 centimeters apart. It can be also up to half a meter. It's a relatively short range of the application.
signature.
And we are talking about
The motor, like,
harvested kind of energy of about 10 milliwatt, which is more than needed for this type of application for this.
continuously set